Hello everyone, welcome back to the channel uLearn Education Online.
Now we are here to see another model based problem on the concept of inverting amplifier. So this is the circuit they have given. For this circuit we have to find out what is the output voltage V0 and what are the current flowing through the resistors. Okay, so how we are going to find out these values, now we are going to see. First, if you clearly observe, this circuit is simply a single input inverting amplifier circuit. So for the single input inverting amplifier circuit, we know the output voltage V0 expression as minus RF by R1 into Vi. So from the circuit we find out RF as 60K and R1 as 10K, and in the question they have given Vi as 1 volt. So finally V0 value is minus 6 volts. And here the next one they have asked is to find out the current flowing through the resistors. If you observe, I is the current flowing through the resistor 10 kilo ohms. So for this the I, one terminal is Vi and the other terminal is connected to Va. So from the virtual ground concept, the Va and Vb voltages are same. Since from the circuit the Vb is connected to ground, therefore the Va is also connected to ground. So we can write the current flowing through the resistor 10 kilo ohms as Vi minus 0 by 10K. Okay, so Vi they have given as 1 volt. So 1 by 10K, which is equal to 0.1 milliamperes. So this is the procedure how to find out the current flowing through the resistor 10 kilo ohms. Next we have to find out what is the value of current I1 flowing through the resistor 60 kilo ohms. You can use the same procedure what we have applied here, that is the I1 current we can write as Va minus V0 by 60 kilo ohms. Va is 0 and V0 we have find out, that is minus 6. So 6 by 60 kilo ohms, that is 1 by 10K, which is also 0.1 milliamperes. Okay, that is one method. The other method is, if you clearly remember the theoretical concept of inverting amplifier circuit, we know that for the ideal op amp the currents flowing through the inverting terminal and non-inverting terminal is 0. So whatever the current that is entering at node A is always equal to the current that is leaving from node A. So we can say that I and I1 are equal. Okay, so the value of I and I1 are equal. So from this I1 is 0.1 milliamperes. Okay, next we have to find out what is the value of current IL that is flowing through the resistor RL. Simply apply the rule, that is 0 minus V0 by 1K. So V0 value we have already find out, that is minus 6. So it is plus 6 by 1K, which is equal to 6 milliamperes. So the current flowing through the resistor RL is 6 milliamperes. At last we have to find out what is the value of I0. So I0 is nothing but, if you apply the KCL at this node, so it is a leaving current and the entering currents are I1 and IL. So from the basic expression rule of KCL, the algebraic sum of entering currents is equal to the algebraic sum of leaving currents. So we can write the I0 expression as I0 is equal to I1 plus IL. Since I1 and I are equal, we can write as 0.1 milliamperes, and we have find out the value of IL is 6 milliamperes. So finally the value of I0 is 6.1 milliamperes. So this is the procedure how to find the current flowing through the branches and the output voltage of a single input inverting amplifier.